Good morning. It's time to get started with our first math lesson of the year. I know I'm excited to jump into things. I hope you are. Get some learning going. We're going to get started and we're going to start figuring some things out. Thank you so much for working to take your diagnostics test in IXL. As we move forward, we're going to start using some of those things to build up our skills. And this is one of our first skills of the year that we're going to be doing in there, but also the first lesson for our Eureka math unit. The materials that you're going to need for this lesson are listed up here. You should have your math notebook, and I'll talk about that in a second. Your math notebook, a pencil to write with, as well as the pages from the lesson that are included in the packets that were sent home. So you should have all those materials. If you don't have those, you can go ahead and go get those. And now I'm going to talk about what that math notebook is. So the math notebook, you were given a few notebooks along with your materials, and I want you to choose one and label it math. So right on the outside of your notebook, I want you to write math. It doesn't matter which color you choose, so if you want to use red or green or blue, it's your choice. But that notebook is going to be your math notebook, and we're going to keep notes in there throughout the year. And it's going to be important that you have that because there are certain things that we want to keep in line and that you can refer back to, because things will start to get a little complex. I'm not going to lie about that. But as long as you can keep those notes in an organized fashion, which I should be able to help you with, you will be able to follow along and do things very well. And I'm confident of that. Now I'm going to talk about the objective for our lesson today. So this is the one thing that I want you to be able to do by the time we finish today, is I want you to be able to solve and find a unit rate. A unit rate is something that we'll talk about shortly as a part of our lesson, so you may not even know what a unit rate is, and that's okay. Maybe you remember a little bit about it from 6th grade, but either way, by the end of this lesson, even if you don't know what it is at all, or if you do, I want you to be able to find a unit rate when I give you a ratio. And so these are going to be two of our key vocabulary words. And we'll get to vocabulary in a minute, but these are going to be things that I'm going to have you write down in your notebook. So right away, I want you to open up to your first page, and this is going to be a page that we are going to write definitions for. So open up to your first page in your notebook and write on the top, definitions. Here we have some key terms that you're going to write in your definitions sheet. You have the same exact thing on the lesson that's printed out for you. So if you would like to use that instead, feel free. So some key terms. You need to write the definition of a ratio. A ratio is an ordered pair of numbers which are not both zero. What does that mean exactly? Well, a ratio, okay, so ratio is the word that we're defining here. Ordered pair. So it's an ordered pair of numbers which are not both zero. So it's two numbers, a pair of numbers that are in an order, that are in a specific order, and neither of them are zero. Okay? So a ratio could be 3 to 2. 3 to 2 is a ratio. It's an ordered pair of numbers. So what that means is a ratio changes if you change the order of the numbers. But for your notebooks, write down, a ratio is an ordered pair of numbers which are not both zero. Here's an example of how to write a ratio. A ratio is denoted A, and we call this a colon, B. A colon B. And A represents a number, and B represents a number. So for example, I just said a ratio of 2 to 3 would be how we would write that as a ratio this way. 2 colon, which is those two dots, 3. to indicate the order of the numbers. The number A is first and the number B is second. So again, letters A and B here just represent numbers. So 2 and 3. And we'll talk about what that means in a second. What actually do these numbers mean when we get down to our example? All right, another thing you need to write in your notes is equivalent ratios. That's our next vocabulary term. So you should have ratio written down with the definition, and now on the line below that, or if you want to leave some space between, that's okay too, write equivalent ratios, and that's the next term we're going to define. Two ratios, A colon B and C colon D. Okay, so again, remember these letters represent numbers. Okay, so we could put a number in place of those letters. If we put numbers in place of those letters, that's how we actually create a ratio. A colon B isn't actually a ratio, it's just an example, and these two letters are holding the place where we would actually put a number. So two ratios, so A colon B, or A colon B is a ratio, and C colon D is a ratio. So they are equivalent ratios if there is a non-zero number C such that C equals C times A and D equals C times B. That is a big mess, and we're going to talk about what those things actually mean in a second. For example, two ratios are equivalent if they both have values that are equal. And again, we'll discuss exactly what that means, and we'll refer back to this. But for now, what you need to know is that equivalent ratios, okay, and this is what you should write in your definition, two ratios are equivalent ratios if you can multiply or divide one. So let's say we have two ratios here, 2 colon 3, and so a ratio would be equivalent to 2 colon 3 if you could either multiply it or divide it by the same, or by one number to equal 2 colon 3. And I know that sounds confusing. We'll get to it in a minute. If you still don't fully understand the definition of equivalent ratios, maybe wait on that and we'll come back to it, and maybe you'll feel better about the definition there, because this is pretty wordy. Okay, so a ratio relationship between two types of quantities, such as 5 miles per 2 hours, can be described as a rate. The quantity 2.5 miles an hour. Okay, this is not a definition, this is just explanation. So what that means is we can have two different types of quantities, 5 miles and 2 hours. Miles measures distance, hours measures time. So if we take 5 miles per 2 hours, so 5 miles for every 2 hours, that would be an example of a ratio. 5 miles per 2 hours. We could write that as 5 colon 2. Okay, 5 for every 2 hours. And that's really what this starts to mean. And we'll discuss that in a second here. Lastly, the numerical part of the rate is called the unit rate, and is simply the value of the ratio, in this case 2.5. So if we were going to divide 5 divided by 2, and if you need a calculator at any point, you can use the one on your Chromebook. So if you need to, you can feel free to open a new tab and use a calculator there. In this case, 2.5. So they said, going back to this relationship, 5 miles per 2 hours, the unit rate here would be 2.5. Because when we divide 5 by 2, we are going to get 2.5. And again, we'll get to that in a second. That means that in 1 hour, the car travels 2.5 miles. The unit for the rate is miles an hour, red miles per hour. All right, I'm going to erase the board here, and let's get started with our first example. So normally, what we would be doing here in a normal year, we would be taking the time to practice writing out ratios using an activity where we would pass papers around in the room. However, in this situation, because we're not in person, we're going to do things a little bit differently. And I'm just going to create some of our data here, some of our information that we will use to answer the questions. All right, so here you can see a few pieces of information. We have our trial number, so we're going to do this 4 different times, okay? And in this example, what we would be doing is passing papers around the room, and we would take a certain amount of time to do that. And then we would figure out, by doing some math, we would figure out what's the ratio of the number of papers we passed to the amount of time it took us, and then we would figure out the unit rate, which in this situation would be how many papers did we pass in 1 second or minute, or depending on what we used for our unit of time, that's what we would also use for our unit rate. However, okay, so let's say, for example, if we were all in person and we were able to do this exercise, let's say the first time we did it, we were able to pass 30 pieces of paper in 45 seconds. All right, so you can copy this down as well in your notes and follow along here. So in our first time we tried it, we had 30 pieces of paper that we passed in 45 seconds. Now, we need to come up with a ratio of number of papers passed to the time. So think to yourself, okay, remember, first of all, how do we write a ratio? How do we write it? The way we write a ratio is, remember the formula they shared earlier was A colon B. And A and B don't stand for, or they are placeholders for eventual what? Okay, eventually we would use numbers. So these are placeholders for numbers. So if we're going to write, if this is how a ratio is written, a number, a colon, and another number, okay, and we want to write a ratio of the number of papers passed to the time, so we need a number that represents the pieces of papers passed to the time. So the number of papers we passed was 30, so for my ratio comparing, remember a ratio is, it compares two things. It's a relationship of two different numbers. Okay, so in this situation we have time, or we have number of papers and a time. So it's a way of comparing two numbers that are used to measure different things. 30 papers passed in 45 seconds. So our ratio of number of papers passed is 30 to 45. Now we need to find the rate. Okay, so what would the rate be that we passed these? Well, we passed 30 in 45 seconds. So our rate that we're going to need to find is how many did we pass in, say, how long did it take us to pass a single piece of paper? Or how long, or how many papers did we pass in 1 second? How do you think we could go about finding the answer to that question? How many papers did we pass in 1 second? If we passed 30 in 45 seconds, how many did we pass in 1 second? The way that we're going to find that is by dividing. We're going to divide 30 divided by 45. Okay, and that's going to give us our rate. 30 divided by 45. Okay, so now thinking, if you divide 30 into 45 groups, do you expect your answer to be more than or less than 1? If we have 30 of something and we're trying to divide it into 45 groups, okay, we should expect our answer to be less than 1, but still greater than 0, because we're not passing a negative number of papers. We just aren't passing very many in 1 second. So once we've divided that out, you should get, let me just think here, 30 divided by 45 should be 0.66 repeating, okay? And we can show that with a line over the top of our numbers, or you might prefer to do the dot, dot, dot afterward. We call that an ellipses. 0.66, remember this refers to papers. So we passed 0.66 papers for every 1 second. We passed 0.66 papers in 1 second. So why did we get a number that's 0.66 papers? How can you pass 0.66 papers in 1 second? How do you even pass, because we didn't cut the pieces of paper, right? We didn't cut them into, this as a fraction would be 2/3. We didn't cut it into 2/3. Okay, so the reason is because we passed fewer than 1 for every second that went by. This is our average, okay? Our rate, okay, is an average. It's not that saying that we actually passed that many, but that's the average. So over 3 seconds, we passed 2 papers, which would be, okay. Okay, so how do we get from our rate to our unit rate? The way that we're going to do that is, our unit rate would just be 0.66, because that is the number of papers we were able to pass in 1 second. A unit rate is always going to be out of 1 whatever, okay? Or rate will be in 1 something. So let's say I had 50 pieces of candy and I wanted to know how long that row of pieces of candy would be. Okay, so let's say 50 pieces of candy is 100 inches, for example. Okay, so that ratio would be 50 to 100. My rate, I would divide 50 divided by 100 to get my rate. And that would give me half a piece of candy for every 1 inch. So my unit rate would be 1/2 inch, because 1 piece of candy would be 1/2 inch. Maybe that's confusing. Let's just stick with me, though, and let's take another trial. Let's say for the second time we tried to pass papers. We passed 100 papers in 200 seconds. Okay, time in seconds. So 100 pieces of paper in 200 seconds. My ratio is comparing the number of papers passed to time. Whenever we use that colon, that can always stand for the word to, or compared to. All right? So 100 pieces of paper to 200 seconds. 100 to 200. And so that rate, remember, how do we find that rate? What do we have to do to these two numbers to find the rate? Here, take a look at here. This is what we did to get the rate. What do you think we will have to do to these two numbers to find our rate? To find our rate, we're going to have to divide 100 by 200. So this is going to be 100 divided by 200. You can do on your calculator. Is going to be 1/2, 1/2, or, which is also 0.5. So we passed 0.5 papers in 1 second. How did I get that 1 second? Well, when we divide 100 divided by 200, we're saying 100 divided into 200 groups. So each second then, okay, if we divided 100 papers into 200 groups, that would be half of a paper for every 1 second. Okay, and that's what we're writing here. Half of a paper in 1 second is the average that we passed. And so my unit rate is going to be 0.5. Let's try another one. Let's try 50 papers in 25 seconds. All right, now let's make our ratio. Hopefully you've got it by this point. The ratio is comparing number of papers passed to, which is our colon, to time. So the number of papers we passed, 50, to 25 seconds. Now, looking at these numbers, we passed more papers this time than seconds. So would you expect, if we divide these two, is our answer, did we pass more or less than 1 paper a second? If it took us 25 seconds to pass 50 papers. Okay, so again, to find our rate, we're going to divide 50 divided by 25. 50 divided by 25 gives you 2. So what do you do with that 2? How do you get the unit rate from 2? Or how do you get the rate from just the number 2? Well, think about what we're dividing. We're dividing the number of papers passed divided by the amount of time it took us. So what that's going to tell us is still, okay, that 2 is telling us the number of papers we passed in 1 second. Just like here, when we got 0.5, it told us we passed 0.5 papers in 1 second. 0.66 papers in 1 second. 2 papers in 1 second. Now that's way faster to pass 2 papers in 1 second. That's pretty quick. Then our unit rate, hopefully you remember by now, okay, basically we're just writing this. The rate is a ratio, okay, and it's comparing the number of papers to a second, 2 papers, okay. So this unit rate here, we pass 0.66 papers in a second, 0.5 papers in a second, 2 papers in a second. Let's do our 4th trial here. All right, let's say this time we just had lunch and you all loaded up on a whole bunch of candy during lunch, and so you just are full of energy and you're just ready to go, okay? So let's say I gave you 100 papers and we finished them in 25 seconds. All right, go ahead and do this. Fill it out on your own. Here are the answers to those questions. Hopefully you got that right. If you did, awesome. If you didn't, take some time and continue thinking about where we are getting these numbers from and how we are getting our unit rate from those. So that's up to you. You need to, if that's something that you don't understand, take the time to review it for a little bit before moving on to the next part of the video. If you do have it, at this point, we are ready to move on to the next part of our lesson. Okay, so let's think back to some of those vocabulary terms that we had at the start of our lesson. Okay, so we had a ratio. Okay, and remember, our objective here is we want to be able to take a ratio and end up with a unit rate. So let's think back. Okay, a ratio is an ordered pair of numbers. An ordered pair means that it's 2 numbers in an order, and they're both not 0. 1 to 2 is a ratio. 1 to 0 is not. And the reason 1 to 0 is not a valid ratio is because you can't divide 1 divided by 0. That's not going to, you can't divide a number by 0. It just doesn't work out properly. All right. We have not yet gotten to equivalent ratios, okay, but we will. An equivalent ratio basically means that when we divide those 2 numbers, we should be able to, okay, the word equal is in here. Okay, equivalent ratios are ones that would be equal to each other, and we will get to that in a little bit. All right, so we've talked about the ratio relationship between two different types of quantities. Okay, so we're not comparing 2 seconds to 1 second. Okay, we could. Okay, at this point, we are talking about miles and hours, or papers in seconds, or pieces of candy and number of inches. Okay, and so the numerical part of the rate is called the unit rate, and is simply the value of the ratio. So if we were to divide 5 divided by 2, we get a unit rate of 2.5. It's the value of the ratio without any of the labels, like you should have seen in our examples down below. Okay, so that means that this car that traveled 5 miles in 2 hours is traveling in 1 hour 2.5 miles. Because when we divide 5 divided by 2.5, we will get 1 hour, because that is, that's our unit rate. That's our unit. Okay, so it's the rate per the unit. Our unit there would be hours. So if in 1 hour, the rate is 2.5 miles. Let's move along now. All right, let's take a look at our class by gender. Okay, so we only have one class. Okay, but let's just say, for example, we had a class that was, let's say we're comparing our school to another school. And I don't know this off the top of my head. I'd have to look at the roster. Okay, and I don't have you in front of me, so I can't do it that way. But let's just say we have 8 boys and 8 girls. I know you can do this by now. Write the ratio of boys to girls. Class 2, let's say they're a much larger group. Let's say they have 12 boys and 12 girls. So the whole 7th grade class then would have 20 boys and 20 girls if we were adding both of these together. Okay, 2 different classes and then the whole group together. So our ratios then will be 12 to 12, 12 boys to 12 girls, and 20 boys to 20 girls. All right, and here I want to talk about equivalent ratios for a second. So we've talked about ratios. We know what a ratio is. It compares 2 things. It shows a relationship between these two numbers. Okay? So in this situation, all right, if we were to find the rate, okay, so let's say in this situation we're finding the rate for every 1 girl, how many boys are there? All right, that's what the rate is telling us. Just like earlier, we were saying for every second, how many papers did we pass? For every inch, how many pieces of candy were there? Okay, so for every girl, how many boys are there in this situation? Okay, there's 1 boy for every 1 girl, right? So in this situation, I'm just going to add another column there. Our unit, or our rate, is 1 boy for every 1 girl. 1 boy per girl. In this situation, if we have 12 boys and 12 girls, how many boys and girls how many boys are there for each girl in the class? Well, they're the same number again. So it's 1 boy per girl. Here again, when we have the whole group, 20 boys and 20 girls, for each girl, how many boys are there? There is 1 boy per, or for each girl. And how did I get these numbers? Just like in the previous steps, if I divide 8 boys divided by 8 girls, I get 1. And that 1 is telling me 1 boy per girl. If I have 12 boys and 12 girls, and this is what we did before in the last example, 12 boys divided by 12 girls. We get 1. And that 1 tells us 1 boy per girl. Same thing, we could do the same thing with 20. Okay? This ratio is 20 boys and 20 girls. If we divide that, that tells us the rate per girl. And then the unit rate, remember, is just this without the label. So our unit rate in this situation would just be 1. Here, 1. Here, 1. The unit rate in all those examples would be 1. Okay, so now let's talk about an equivalent ratio, or an equivalent ratio. An equivalent ratio is going to be one that has the same rate as another. All of these ratios give us the same rate, and that means they're all equivalent ratios. Okay, so if I'm going to divide this number by this number, it gives me 1. If I divide this number by this number, it gives me 1. That means they both have the same rate, and that also means they're equivalent ratios. That means they're equal to each other. Okay? So an equivalent ratio does not mean that there are the same number. Okay? So here there are 8 boys, and here there are 12 boys. Equivalent ratio does not mean that there are the same number of boys in each group. It means that the relationship between the boys and the girls is the same. So for a ratio to be equivalent, the relationship between these, or the rate, has to be the same. So let me give you a few more, and I want you to decide in your head which ones are equivalent ratios, okay, to 8 boys to 8 girls. Find the ratios that I write. Find the ones that are equivalent to this ratio. Let's say 100 to 100. Is this ratio equivalent to this ratio? To find out, what do you need to do? We need to find the rate. We're going to find the rate by dividing these two numbers. Remember, with a ratio, we can divide this number by the second one to find the rate. 100 boys and 100 girls divided by each other. So 100 divided by 100 equals 1. These are equivalent ratios. What if I did 100 to 99? How can you tell? Well, we're going to divide. 100 divided by 99. Okay, you can do that yourself. And if it comes out to 1, it's equivalent to this ratio. If it does not come out to 1, it is not equivalent. So now you need to create a pair of equivalent ratios by making a comparison of quantities discussed in this example. So you're comparing boys to girls, comparison of quantities. So you need to create a pair of equivalent ratios, okay, so that the unit rate of both of your, the rate of both of your ratios, or the unit rate of both of your ratios, is the same. Go ahead and do that right now. Moving to the example right below now, we are going to start making use and actually using these ratios and these unit rates for our benefit. But before we begin that, think again about our objective. Our objective is to be able to take a ratio and find the unit rate. If you think right now that you can do that, fantastic, and you are on track to being able to complete our assignment. Let's take a look back here, though, at, so this is just below the example we completed, which is the better buy. And so what we're going to do in this exercise is figure out which which of these options is going to give us more for our money. And we're going to do that finding a rate. Value Mart is advertising a back-to-school sale on pencils. A pack of 30 sells for $7.97, whereas a 12-pack of the same brand costs $4.77. Which is the better buy, and how do you know? This is a word problem now, okay? We don't just have a chart with numbers. We need to get information from this. And there are some really important pieces of information that I want you to remember. Okay, so when we are going through this, we're going to look for, first of all the important things in there. One thing that you should always look for in a word problem is what numbers do I have, and what is the question asking me to figure out. Once we have those pieces of information, we're going to figure out how all the numbers fit together to get us our answer. All right, so just looking through here, I'm thinking, okay, so they're advertising a sale on pencils. Okay, all I really care about is they're selling pencils. Okay, this is not very important. Okay, so they're selling pencils. Okay, a pack of 30 sells for $7.97. Okay, so that's important. We've got a couple numbers there. So let's just underline that. 30 sells for $7.97. Okay, a 12-pack, there's another number, 12-pack of the same brand costs $4.77. Okay, now so I've underlined all the important numbers and all the pieces of information there. Now I need to know, what is it asking me to do? Which is the better buy? So what is it asking me to do? I need to find out which of these prices or which of these options is going to get me more for my money. All right, so my pieces of information, 30 pack of 30 pencils, so 30 pencils for $7.97. And then I've got a 12 pack of pencils, so 12 pencils for $4.77. How can we take these pieces of information and what we've just learned about ratios and come up with ratios or something that can help us to figure out which is the better price? Here I'm going to create a ratio, okay? So I want to know, let's see, how should we set up the ratio? Okay, so we know that these two pieces of information go together, and these two go together. Remember, the second number in our ratio is always going to be what we're solving for, okay? So remember, the second number was the number of seconds, okay? So we were solving for 1 second, how many papers did we pass? So in this example, do we want to figure out how many pencils we get for 1 cent, or do we want to figure out how many cents we're paying for 1 pencil? I think it makes more sense to solve for 1 pencil, so I'm going to put that piece of information second in my ratio. So my ratio is going to look like this, 7.97 to 30 pencils. Now let's write the ratio for 12 pencils. Remember, again, I want to solve for the cost of 1 pencil. So 1, okay, is my unit. 1 pencil is my unit, so I want to put that second. 12 pencils, okay, $4.77. $4.77 for 12 pencils. All right, now how do I know which of these is the better option? Maybe you could do some mental math, okay, but we are going to find the rate. We're going to find the number of cents or dollars for 1 pencil in both of these options. And then the one that is fewer cents per pencil will be the better price. So let's do that by How do we get from our ratio to our rate? $7.97 divided by 30. And I'm going to do the same thing here. $4.77 divided by 12 pencils. And the answer we get should tell us the price per pencil. All right, so I divided those and I got 0.265 and 0.397. Okay, what do these numbers mean? Remember, we are trying to find the price per pencil. When we divide that out, it tells us this is the cost of a single pencil. Remember our unit that we're solving for. Okay, so pencils in this case. This tells us the cost. If we divide 7.97 divided by 30, that tells us the cost per one pencil. So I'm going to write this as 0.265. Okay, now this is a dollar amount, right? $7.79, $4.77. So this is $0 and 0.265 cents. What do we do? Because remember, for cents, we only want two places. We don't talk about having 265 cents. And this isn't 265 cents. Okay, it's $0.265. This would be 26.5 cents. So we need to get this down to just two places. If we have a 5 here, do we want to round that number up or down? We want to round that up. Anytime the digit that we're rounding using the number that we're rounding off or cutting off is going to tell us, okay, if this number is 5 or greater and we're cutting it off, we're going to bump this number up 1. If it's 4 or lower, then we just get rid of it and we leave this number the same. So in this situation, 0.265 will actually erase to 0.27. We're rounding up. So it's 27 cents for one pencil. Now let's take a look at this one. Okay, first, we have got too many decimal places. We need to round. Do we round up or does it stay the same if we have a 7? It's greater than 5, so we're going to round up. All right, so if we're rounding up, that means this 9 will become what? A 10, right? 9 plus 1 is 10. So we can't write 310. We have to just bump this number up to 4 then. So it's actually going to become 0.40 or 40 cents per or for each, for one, per one pencil. And this is our rate, 0.27 per one pencil, 0.40 for one pencil. That should be an E, not an O. Por is a Spanish word, it means four. Okay, so now that we have our rate, that rate should tell us which is the better value, which is the better deal. Before we use that though, okay, now that we have this, what would be the unit rate? Remember our objective, we need to be able to find the unit rate, not just the rate. The unit rate here is this number without the label. So it's 0.27 and 0.40. These are our unit rates, okay? For one of the unit, this is for one pencil, it's 27 cents. For one pencil, it's 40 cents because pencils is our unit there that we're solving for. So now, which of these is the better value? Well, if I'm paying 40 cents per pencil, or I could pay 27 cents per pencil, that's the better deal. I pay less money. Okay, this is what grocery stores will do too. Usually if you buy more of something, you end up paying less for each individual one. If you buy a family-sized bag of chips, you're paying less per one chip than if you bought a small snack-sized bag of chips. All right, so that one's the better buy. Which one is the better buy? The one that's 30 pencils for $7.97. So the better buy is the 30 pack of pencils is the better buy. All right, how do you know? Because the 30 pack of pencils costs 27 cents per pencil for one pencil. The 12 pack costs 40 cents per pencil. That's how we know, because it's a cheaper price per pencil. All right, we are at the end of our lesson. So if you are feeling confident, okay, let's take a look at our summary. Unit rate is often a useful means for comparing ratios and their associated rates when measured in different units. So it's a good way to compare two different ratios. Okay, we find the rate, we find the unit rate, and then that'll tell us how those ratios compare. The unit rate allows us to compare varying sizes of quantities by examining the number of units per one quantity. So per one pencil, we were able to find two different prices, okay, two different quantities, and examine them and find out the number of units of one quantity per one unit of the second quantity. So how many units, or how many cents per one pencil of the second, okay, so the second quantity, the second number was our pencils. This value of the ratio is the unit rate. If you are feeling confident, you can go ahead and head back to Google Classroom and find your homework assignment there, okay, and complete it on paper, okay? Or if you're not feeling comfortable yet, you can continue watching the video and I'll go through one or two more examples. I appreciate you sticking around if you're still here and doing this with us, okay? Nothing wrong with wanting a little more practice. There's absolutely nothing wrong. Maybe it'll even help you with a couple more challenging questions. All right, so here we're going to work through a couple more. So the first few word problems are giving you some numbers. So let's work through a couple practice problems that are like that. Okay. Find each rate and unit rate. So I'm not going to go through these because these are your homework. However, we can try some practice ones that are similar. All right. So let's say instead of 420 in 7 hours, we're going to travel 30 hours. No, let's not do that. Let's say we're going to eat 3 candy bars in 2 hours. 3 candy bars in 2 hours. Okay, just like one of these examples. 420 miles in 7 hours. Okay, 3 candy bars in 2 hours. So how do we find a rate and unit rate from that? Okay, remember our steps. First, we need to start by turning this into a ratio before we can find the rate. All right, so should we solve for the number of candy bars that we ate in 1 hour, okay, which is how this is set up, or do we want to solve for the number of hours it took us to eat 1 candy bar? Okay, I think it makes more sense to figure out the number of candy bars we ate in an hour. So remember, if we're doing that, then the one that we're solving for, okay, if we want to find out per hour, okay, for in 1 hour, then we want to put that number second in our ratio. Okay, we write a ratio 3 for 3 candy bars, 3 to 2. 3 candy bars to 2 hours, okay, in 2 hours. Now that we have our ratio, we can find our rate. The step that we take to get from ratio to rate is we divide the first number by the second number. 3 divided by 2. 3 divided by 2, do that on your calculator or in your head. That should give us 1.5 Remember, that's referring to candy bars in 1 hour. In or per 1 hour. Fantastic. That is our rate. So if we were finding the rate, we would be done with that part. Then the unit rate is this number without the words. Our rate, or our unit rate, is 1.5. Let's take a look at one other example then of one of these word problems that follows. All right, let's take a look at this. If you need to any extra space on your paper, by the way, you can also use some of those back pages from your notebook. Those should be helpful that way as well. All right, let me just move down here a little bit. Let's see. Let's take a look at some of these. Okay. Mr. Rowley has 16 homework papers and 14 exit tickets to return. Ms. Rivera has 64 homework papers and 60 exit tickets to return. For each teacher, write a ratio to represent the number of homework papers to number of exit tickets they have to return. Are the ratios equivalent? Explain. So we have a lot going on here. Remember, we want to start by finding the important information, and then we'll work from there. Okay? Important information. The numbers. Numbers are important, and then after that, the other important pieces of information are, what do they want us to solve for? What are they asking us to do? All right, so this is one person. I see numbers. 16 homework papers, 14 exit tickets. Okay, so that's example one. Okay, the first person has 16 homework papers and 14 exit tickets. Ms. Rivera, the second person, or our second ratio, has 64 papers and 60 exit tickets to return. For each teacher, so we're going to write a ratio to represent, okay? So we're going to write a ratio for Mr. Rowley and one for Ms. Rivera to represent the number of homework papers to number of exit tickets they have to return. All right, so we're going to start with that. So I'm going to change the numbers just for an example, so I'm not doing a homework problem for you. So let's just say Mr. Rowley instead had 20 homework papers and 18 exit tickets. Ms. Rivera has 50 homework papers and 32 exit tickets. Okay, so Mr. Rowley has 20 papers and 18 exit tickets. Ms. Rivera has 64 papers and 60 exit tickets. So before we can check if the ratios are equivalent, we actually have to have ratios. And remember, the way that we check if ratios are equivalent is by comparing the rate or the unit rate. All right, so let's create ratios for these two. All right, in this situation, I don't think it makes as much of a difference if we want our unit to be exit tickets or homework papers. We're just kind of comparing here to say, do they have the same ratio? Okay. So in other situations, it makes more sense. Here, because it's something, we'll just leave it how it is because it doesn't really make sense to divide it a different way. Okay. So to find our ratio, 20 homework papers, 20 homework papers to 18 exit tickets. Ms. Rivera has 50 homework papers to 32 exit tickets. Now, just because these numbers are different does not mean that the ratios are not equivalent. Okay, so don't just finish the problem there. Make sure you go through all the steps. So now that we have those, what do we need to find? For each teacher, write a ratio. So we wrote the ratio that represents the number of homework papers to a number of exit tickets. Okay, that's what we did. Homework papers first, exit tickets second. Homework papers to exit tickets they have to return. Are the ratios equivalent? And explain. To do that, we need to find the rate. To find the rate, we we need to divide the ratio. 20 divided by 18, and 50 divided by 32. All right, let's do that on my end. 20 divided by 8 gives me 1.1 repeating. 50 divided by 32 gives me 1.562, okay? So make sure these match up. I'll just add these extra ones. All right, so what do these numbers tell us? This tells us, well, remember here, this stands for homework papers. This stands for exit tickets. So 1.111 homework papers, and we're always solving in terms of the second, in the unit of the second one. So 1.11 homework paper per one exit ticket. 1.562 papers per exit ticket, or per one exit ticket. So are these equivalent? No, because the relationship isn't the same. Okay, here we have 1 for each exit ticket. Here we have over 1.5 for each exit ticket. So those relationships between those two numbers, okay, they aren't the same. Okay, they aren't the same. And so those are not equivalent ratios. In order for these to be equivalent ratios, we would have had to get 1.1 repeating right here. So remember, when you're doing these word problems, look for the important pieces of information, then look for the questions that they ask you and the things they ask you to do. Okay? And so the explanation, there are fewer homework papers per exit tickets. There's only 1.1 per exit ticket. Here there's 1.562 per exit ticket. Okay, so the ratios are different. There are more homework assigned papers compared to the number of tickets. So again, when you're going through these, make sure you answer the questions. And when you're answering, then you start to figure out how the numbers fit together. Don't try and put the numbers together before you know what we're trying to do, because that can throw you off task a little bit. All right. So hopefully by this time, you know how to get a unit rate from a ratio. Or maybe not even from a ratio. Maybe just from two numbers. All right. Good luck with your work. You can head back to Google Classroom and your assignment will be listed there. Then you can complete it on this sheet. If you would like, you may also use pages from your notebook. Don't use your vocabulary sheet, but you can use pages from the back of your notebook or the loose paper that was sent home with you to use as scratch paper as well. Then you're going to upload your assignment using a picture on Google Classroom. All right, go get it, go do it, and we'll see you tomorrow.